Let's look at some more examples of finding domains from equations. So the first step is let's look at the first problem. Let's find the domain of, and let's do square root of 15 minus 3x. Let's let that equal to h of x. Right, in that case, the key is that we can't, remember, when we're finding the domain and range of functions, there's three rules we have, the domain of function, there's three rules we have to worry about. You can't have a negative underneath the square root sign, you can't divide by 0, and you can't have log of a negative number. And this is done later in the logs. But here what we have is we have that 15 minus 3x has to be greater than 0. Could it be 0? Let's think that through. It's square root of 0 is 0, so that's fine. So it can be greater than or equal to 0. So then we simply solve for what x can be. You have to remember the sign flipping rule. Minus 15 minus 15. So you have minus 3x is greater than or equal to minus 15. And then divide by minus 3 minus 3. When you divide both sides by negative, the sign flips and you get x is less than or equal to a positive 5. So that's your domain. We have to have this argument of the square root has to be positive, therefore x has to be less than negative. Let's look at another example. Let's find the domain of, let's do x squared minus 16 over x squared minus 36. So let's think about this. Are there any square roots? No. Are there any logs? No. Are there any denominators? There is a denominator. So what happens is this denominator cannot be equal to 0. So we're going to solve for x squared minus 36 is equal to 0, and that's what it can't be. Sometimes people use notation as x squared minus 36 not equal to 0, however you would like to do that. So the first thing, there's two different ways to solve this. You could factor this if you want to, or you could, in that case, it'd be x plus 6 and x minus 6 not equal to 0. X plus 6 is not equal to 0, or x minus 6 is not equal to 0. X can't be minus 6 or positive 6. So in this case, the domain is everything, is all real numbers. Let's use this. This is often the symbol for all real numbers. So I use this, all real numbers. But x is not equal to minus 6. X is not equal to 6. Let's think about how we would write that in interval notation. To write that in interval notation, what we'd like to do is first just graph it out. It's everything except for minus 6. Let's put an open dot there, and 6, put an open dot there, and then it's actually going to be everything else. So this is a case where it's an easy problem, but the notation can get a little confusing, so let's go over that carefully. This is your domain. It's just a graphical representation of your domain. Domain is the entire number line except for 2 points. So when you write an interval, you write the more negative number first. So the most negative number here is minus infinity, and it goes to minus 6, and then there's a break or discontinuity. It doesn't include minus 6, so we put a parentheses. And with the infinity, we always use open parentheses. So the key is this is open parentheses because it's an open dot. Let's look at the next part of the graph here. That starts at minus 6. Start with the most negative first, and then go to the most positive. So it goes from minus 6 to 6. They're both open parentheses because they're both open dots. And then the third part of it here is used to go from 6 to infinity. With infinity, use open parentheses always, and we use open parentheses with the 6 because it doesn't include the 6. It's all three of these, right? So it's this one and this one and this one. So the domain looks like this. This is your answer, your domain in interval notation. Let's look at one other problem that's a little more difficult. Let's look at f of x is equal to 5x squared over the square root of x squared minus 25. So the first thing you look at is there any roots? There is a root here, so this, what's inside the root, can't be negative. But since it's a denominator, you also can't divide by a negative. So normally we would say x squared minus 25 has to be greater than or equal to 0, but since it's a denominator, it's actually greater than 0. Right? So it boils down to solving this problem. Now the problem with this is what's called a quadratic inequality. And we'll go over it now, but there's 2 videos on how to solve quadratic inequalities that you can watch. And the basic idea is to solve a quadratic inequality, first get everything on one side equal to 0 and then factor it. This is going to factor to x plus 5, x minus 5 is greater than 0. These are called the critical values, or the zeros. The critical values here are going to be minus 5 and a positive 5. So first you find the critical values, and then you're going to draw a number line. So let's do that next. You draw the number line and put the critical values in. Now the critical values are either going to be closed dots or open dots depending on the type of inequality it is. This is strictly greater than, so they're going to be open dots. So put an open dot at minus 5 and an open dot at 5. Now the key to this is you have intervals here, and the intervals here are either going to be positive or negative, and this is where they're going to change signs. So what I'm going to do now is I'm just going to plug a number in. Take some number that's bigger than minus 5. Say, for example, x is minus 10, and plug it in. If I get minus 10 squared minus 25, minus 10 squared is 100. That's 100 minus 25. So since x is equal to minus 10 is positive, then these are all positive. Now I'm going to look at the second interval. I actually like to draw little dotted lines here to keep the sense that these are 3 different intervals. Choose a number between minus 5 and 5. I'm going to choose x is 0. And plug in x equals 0. 0, then I can plug it into either to the original problem here or here. It doesn't matter. That's going to be 0 plus 5 is 5 times minus 5. 5 times a minus 5 is a minus 25, so that's going to be negative. And then plug any number in here. Let's choose x is equal to, it doesn't matter. Let's choose x is equal to 8. 8 plus 5 is going to be 8, 10, 13. 8 minus 5 is going to be 3. 13 times 3 is 39. That's a positive. So in these intervals, this is positive, this is negative, this is positive. Let's go to see what I want. I want to solve for where it's positive. Where is it positive? It's positive here and there. Does it include minus 5? It doesn't. Or positive 5. So there's my answer. And if you need more help, this is just a quick review of solving quadratic inequalities. If you need help with solving quadratic inequalities, look at the video. There's a video of quadratic inequalities and more. Here's our domain. Our domain, here it's probably easier to write in interlimitation. It's everything from minus infinity to minus 5. It does not include minus 5. It's everything from 5 to positive infinity, and it doesn't include 5. And it's both of these, so it's a union. And that's how you solve finding the domain of functions from equations.